Hey guys, welcome back. So in this video, we're gonna see what OOPS is and why is it related with Java. So let's try to understand why OOPS was invented in the first place, right? To understand the reason why something like OOPS has to come up. So first, let's try to understand what are the data types in Java, or not exactly in Java. If you try to look at any programming language, uh, the programming language comes up with something called as a primitive and non-primitive data types. So usually all these primitive data types, so they are like characters, integers, floating points, and booleans. And when it comes to non-primitives, if it is available in that language, in C we don't even have the non-primitives of classes and interfaces. So we're only restricted to strings and arrays, right? So strings, arrays, objects, and classes interfaces. So why are these classified as non-primitive and why are these things are called as primitive? So what has made all of these things as primitive? It's because when the programming languages were invented, so the sole purpose of those languages was to implement some sort of mathematical function. So that's why most of them were function oriented and they were a procedure oriented. So the main treatment of a language is to implement the mathematical or the abstract mathematical things that we have in our program, right? So to actually bring all those abstract mathematical concepts, we only need something like integers for numbers. We might use some floating points for the decimal thing, and the boolean might be used for storing the true and false such sort of things, and then for any sort of a character, so we have the character, and even strings and arrays are also, they can be called as primitives because they're not exactly the reason why object orientation was created. We still had arrays, so we can create arrays using the primitive types as well, right? So all of these things are used to actually create something which is mathematically plausible, right? So but after 1970s and 1980s, so when the commercialization has happened, so we wanted to create the virtual entities from real entities. So if we were to draw inspiration from real world entities, then we should, then we should have some mechanism to actually make that a transformation from the real world to the virtual world. So with whatever we have, so we have all these characters, floating points, integers, all these primitives and arrays. So they are not sufficient. So we needed something else. So we needed some other mechanism that is going to help us. So if you look at this, so we have the non-numerics and the numeric types. We have integers, floating points, and strings and arrays. So all these types, so we cannot use them to kind of make the transformation into the virtual world. So we needed some way through which we can make all this transformation a bit easy, and create a stream flow that could which can be automated, right? So we can see that primitive data types are only useful to bring the abstract mathematical concepts like numbers, sets, and variables, right? But to build an application, we need to manage data with respect to the real world scenarios, right? Okay, for example, we have a car here. So this is a real world entity, right? So if this is a real world entity, how can I show that in my program? So can I use a variable string and say it's Toyota, it's Honda, it's Ford? No, it's not the way. So you have to capture the entire functionality of this car. So what are the functionalities of this car? Right? A car has an engine, a car is a vehicle, so it has some sort of a hierarchy, right? And also if you look at each of these objects, so we have this Toyota, Honda, so all of them are actually they can be classified as cars, but okay, they are under the class called as cars, but they are not if you were to define what a class is, so a class is nothing but a logical grouping of the real world things. It is going to group it is going to group together the logical things which are common, and which must be which must be present in a certain object for to be classified as an instance of this class, right? So we know the syntax how we create classes and objects. So usually in class we define variables and methods. So the variables define the state and the methods define the functionality or the behavior of that class. And objects have the virtual objects are actually virtual as well as classes, but classes are virtual as well as abstract, because the classes are only used to understand how the object should be like, but it never has a physical existence in the memory, so it cannot be seen as a virtual entity. It's just an abstract virtual entity, but objects are virtual entities, right? So we can call a methods an object, we can change variables, we can change its state, we can do a lot of things with this object. So if you were to look at these two objects, they might look similar, but they have some properties different. So the color might be different. There might be some sort of differences, which will be unique to those objects, and we will have some way we can modify the a predefined behavior by the class. So we can use a mutators. So we have seen this in our examples as well, right? So a car has an engine, a vehicle. Okay, a car has an engine and car is a vehicle. So how is this relationship different? Because if you were to see, a vehicle is actually a car because it will have every, so a vehicle is supposed to have everything which a car has. So it is an indirect relationship that every car is actually a vehicle because it has every property that a vehicle exhibits, and it actually exhibits some more behavior as well, if we were to define it. And a car has engine, so the has a relationship means that it is not fully dependent. Because a car has an engine, it actually doesn't mean that it is a subproduct of engine. So it has a different hierarchy, so we can understand this in the real world, so that we can bring it into our programming, right? So here I define that object is not class. So I think I have explained it, because object will have a physical memory to it. So we can manipulate the object, we cannot manipulate the class. Class is only for the definition. It is going to define how the virtual world, how the virtual object should behave based on the how the real world object is behaving, right? So we have the properties and methods. So using the properties, we can use the getters and setters to manage them. So this is how we define a class. So I'm not going to talk about the syntaxes. Okay, so this is another way of looking at it. So a class is going to have the so a class is like a file. It is going to have all the details of how it should behave, and an object is going to have its own properties, but it is going to comply with what the class is supposed to do, because it is inheriting, right? Fine. Now let's look at the principles of OOPS. So we have four principles. So encapsulation, inheritance, polymorphism, and abstraction. So all of these four things. So 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 there are actually many other principles as well, but I think these four principles have actually shown the difference between working with a procedure-oriented language and an object-oriented language. So if these four principles are implemented, so we can see a lot of difference in how we program, and how we write the code for it, right? So let's look at the first one. So encapsulation. So encapsulation defines how the data is handled in the procedure oriented programming language. Okay, let's see how it actually happens. In okay So if this is a procedure oriented programming language like C. So if you okay, let us say you have three functions, and all of those functions, uh, they have to work on some sort of a global data, right? So how can they access that data? So if multiple functions need a data, so in real world we can say that they are connected through inheritance or something. But in the procedural oriented programming, so there is no way you can define which data has to be consumed by which function, right? So if this is the case, any function can actually access this thing. Any function can access the global data, and there is no restriction on okay, the visibility of the data. So the data will be visible to any function if it is kept global. So any function can use it. So it actually limits the security, because uh, we are allowing the access of an important variable to each and every function. If some other routine can access this function, then it can easily call all this data. So there is no way we can say that, okay, for all these a set of functions, so it is a global variable. I want to group all these functions and my private data into a single entity. So it is sort of difficult, and we are not able to achieve it using something called as structures in C. So in a C++, they have defined some mechanism through which we can combine a function and variables. So they made a structures to be capable of holding a function, but again, it is not a safer mechanism. So we have introduced the encapsulation in object-oriented programming, through which we can define a class, we can define all the data members which are needed, and then the behavior or the methods. So these methods are going to work on the data, and it is going to manipulate the data. It is going to do computation, or it might just show you the data. So whatever the behavior that you're expecting, it can only be achieved through the methods. So you don't. So usually we keep all those variables as private, so they cannot be accessible easily. So in this way, by keeping the variables private and the methods public, we're only exposing the methods. So all the variables which are not supposed to be uh, visible to the world will be kept hidden through encapsulation. Okay, here you can see the exact difference how it works. So we have three functions. All these three functions, they are trying to use some sort of global data, so there is no limitation that, okay, if this function 3 also wants to use the global data, it can use the data, but in reality it shouldn't, because whatever the function, okay, the way the functionality was defined, it was not supposed to use it. It was supposed to be kept hidden from the function 3, but no, the global data is available throughout the program, so it can be visible. But in object-oriented programming, I'm going to define my own data and my own functions, and if I want some other functionality, I can use the functions to call the other functions, and it is going to do the computation, and it is going to return me the data, and I can do the same. So in this way, whatever the data which was supposed to be kept hidden will be kept hidden with all those individual objects. Only the functions are exposed, making it a very secure. Right? Now, okay, and this is how the encapsulated objects look like. So an object will have all these public methods using the interaction interface. So we can call all these public methods. So we can have either getters or setters. We might have the constructor. So we have a lot of ways through which we can interact with an object, and all those methods, they internally deal with the private methods and the private data. So there might also be some methods which are not supposed to be visible to the real world, so we are going to keep them as a private methods. Next is the inheritance. So inheritance is nothing but, if in real world you can see that some object, okay, some classes are eventually inherited from another class. So if you were to see that the entire class of humans, so we are derived from the class of animals. So if you were to see the class of animals, so there may be some other class like aquatic and mammals. So we can see that we have a level of classes that are defined. So in a similar way, we can create this sort of a mechanism using inheritance in programming. So usually inheritance is of five types, but okay, let's see what are the types. So we have the single inheritance, so there will be a single subclass and a single superclass, and then we have the hierarchical inheritance in this. So we still have a single superclass, but it will be extended by multiple subclasses. So it is not so much different from a single inheritance. But and and let's see what the multi-level inheritance is. So in multi-level inheritance, so it is nothing but a combination of multiple single inheritances. Like, so a superclass will be extended by a subclass one, and the subclass one will be extended by another subclass two. So so all of the single inheritance and hierarchical inheritance and multi-level inheritance are supported by Java. But as far as the classes are concerned, hybrid inheritance and a multiple inheritance is not possible because of some reason that we might find some sort of ambiguity, as for example that this are two superclasses, so they might have a same function called m. So if we were to call a method m, then so there is no actual way that we can determine from which superclass we are supposed to call it. So there is some ambiguity problem. So we can solve it using interfaces. So we'll see when we come to interfaces. And then we get to abstraction. So abstraction is actually the philosophy of not showing the entire section of the data with us. So we're only going to expose a few things. So only using the few exposed things we are supposed to build upon that. So abstraction can be achieved through abstract classes and interfaces. So abstraction is the method of hiding the implementation details and showing only the functionality. So here we only say what the functionality is, and we don't care how it internally works. So but why is it important to know the functionality? Because only knowing the way it works, we can know how to operate that. So if you don't know how to switch on a device, so then there is no way you can interact with it, right? So you have to know how it so you have to know how to operate that. So you have to know its functionality but not its implementation, because you don't care what happens when you click on a button. So you just want to know what so you just want to uh, get something done, right? So it is your requirement and it is the functionality that you are expecting, and the expected functionality will be given to you. So this is how we write contracts using interfaces. So let's see how the abstraction is implemented. So we can either create abstract classes or interfaces. So how are they different? So they're not actually different, but see here in this example, I can see that these two classes are extending this abstract class. So the reason they extend is because they have something in common in terms of a real world concept. So a circle and rectangle. Okay, let's say this is an abstract class called shape. If this is a class called shape, then we can say that conceptually a circle and rectangle are shapes, right? So we can find some sort of a common concept between them. So if we can find such sort of concept between them, we can write an abstract class and extend that. But if you don't find any sort of relation, so you don't see any sort of hierarchy or concept within that. So in those kind of situation, you can use an interface. So interface will provide you 100% abstraction. It is not going to let you write any implementation. It is just a contract of how a certain application should behave, or how a certain class which is implementing this interface is supposed to behave. I think we discussed about this, and the last one is the data abstraction. So the data abstraction is not so this is very much achieved through encapsulation. So the data abstraction will only allow you to access the methods which or any resources which are made public to you, or or actually there is another way using protected. If you were inheriting it, then also you'll be able to access that. So that's about the abstraction. So interfaces. So let's talk a bit about interfaces. Right, interfaces enforcing the a specification of expected behavior. So interfaces are usually so uh, if for example, if we were to take okay, not polymers. So in terms of interfaces, if we were to take an example, so let us say we have a smartphone here. So a smartphone. if you were to look at it as a class, a smartphone will be extending something called as a mobile phone. A mobile phone might be extending something called as a telephone. So the reason why all of these are extending is because they are of the same class called as a phone. And for a phone, okay, for a telephone, so if it has the ability to be a movable, then we can call it as mobile phone. And if you are extending some other features, then you are making it a smart device, then it is a smartphone, right? But let us say that my mobile phone, it has a music player. So if it has a music player, can I say that okay, my mobile phone is extending a music player? No, because inherently, if you were to look at it as a class, it is, so a mobile phone has to be okay. It has to satisfy this relationship called mobile is a music player. So the is a relationship is not it's not working here. So we can use some other relationship called as has a. A mobile has an interface to play music. A mobile will have an interface to click images, right? So in this way we can define an interface. So it can extend any number of interfaces because there is no limit on its functionality. But we sort of limit its ability to extend more classes because of how the real world entities work. So we did understand why interfaces work. So now let's see how these interfaces are programmed. So okay, so if we have a class can extend a single class, but it can implement multiple interfaces. And if an interface were to implement, okay, if you want to extend the functionality of an interface can in turn extend another interface, right? So we'll see how they practically work in. So all of these concepts are going to be useful in polymorphism. We'll see what polymorphism and how it works. Okay, so now we're coming to polymorphism. So you might have seen about polymorphism, saying that so it gives you the ability to make an object behave differently with a different input. It's kind of same, but uh, you we are supposed to use interfaces to understand the overriding. So now let's see what's an overloading is. So as the word suggests, so in this class called animal, we have a method eat. And if we were to create an object of animal and we were to call the method eat, then we're going to get whatever is implemented here. And if you were to create an object of dog which is extending this animal, and you were to create an object of the dog, and if you were to call the method eat, so since the dog is extending animal, so all of these methods will be present so will be accessible to the dog. So I have two methods, eat and eat a string. So then which method should I call? So at compile time, is there a way that I can know that I have to call this method or this method? Yes. If I'm calling it without any augments, then it is obvious that I have to call this method. If I'm using any augment, then it is obvious that I should call this method. So it can be known at compile time, right? So which method is going to be dispatched uh, for for this object, right? On the other hand, if you were to see the overriding, so it is the same example, but the dog is extending, and it is using the same function. So it is using the same signature, right? If it is using the same signature, then what is the way that I can understand that if I were to call the implementation which is mentioned here or the implementation mentioned here, it will not be known at the compile time. It will be only known, okay, let's say this is my object and I say obj.eat. So whatever the functionality that has to be run will be only known if this type of object is known. So the object type will be only known at the runtime when it's created in the memory. So if it is an object of animal, this will be executed. If it is an object of dog, it will be executed. So whatever the functionality which we are going to see is dependent on the runtime object. So that's why we call it as so So the way that we use the same signature and enforce some new rules, so we call it as overriding. So the method overriding, it will be it. So it is seen as a dynamic polymorphism. It can be observed at the runtime, right? So let's move on and see. So this is what we discussed. So overloading, we have uh, a, a void function with the same name function but different parameters. So based on the way the parameters are called upon, so we can understand which method we are supposed to run. But the overriding example is a bit different. It depends on which class is in existence, so that we be able to call the fun of that object only. Yeah. So this is actually the same example. So this is how you programmatically override your parent class. So it has a method one. So you are also using the same method one, and you're using something called as as a override annotation to actually say that I'm going to override the content. So now we have two methods. Okay, now we have two method definitions. So if you were to create the object of your parent class, so all of this method definition will be worked. And if you were to create an object of your child class, this method definition will be run. So that's how we achieve the polymorphism. So we did discussed, so it is of two types, if it is a compile time or runtime. So if we were to observe the polymorphic behavior at the uh, compile time itself, we can define it as a compile time polymorphism. And if it can only be observed at the runtime, then we call it as a runtime polymorphism. The examples for the compile time polymorphism is the function overloading and operator overloading. In Java, the operators are overloaded by default, and there is no explicit way that we can overload the operators. And for the runtime polymorphism, we can use the function overriding. Right. And yeah, so the abstract classes and interfaces are actually the main reason such a thing like polymorphism is possible. So abstract classes allow you, so abstract classes and interfaces, as they define the functionality and not the behavior and not the implementation. So we can use the method signature and develop our own a functionality to it. And we can only so using only the interface, so we might have a many number of objects which are implementing that. But it is always expected that each and every object which is implementing will have all of the methods which are specified in the interface implemented by them in a abstract not in an abstract way, because if not all of the methods are implemented by the subclasses, they themselves become abstract. So it is always expected that they implement all the methods. So yeah, and there is another topic which is called as upcasting and downcasting. So I think we need to discuss a bit more about this. Okay. So as we discussed that, so okay, let's assume this is the relationship that a child is extending the parent. So now we are trying to, so this is called as reference, and this is the object, right? So here we used a reference P. So this is of the type parent, and we are assigning a new child, right? So is it logically possible, and will it throw me any errors? It actually won't throw you any error, because let us assume that this parent has okay, let's say it has a method A, and the child has a method B. So since I have uh, the reference P with me, and I am pointing to an object of my child. So my child will always have the A as well as B with him, since he is extending this parent. He will have the method definition of A as well as his own definition of B. So as my reference is P, all I know that is I only have a method A. Okay, if I call my method A, so can I exhibit this functionality? Yes, so there is no issue with that. And this is called as upcasting since we are going uh, down the lane. So let us assume another way. So here I said, so my reference is now a child. So here my reference is actually a child class, right? And it is trying to point to a new parent. So will it throw me an error? So since this object is of the type parent, it will only have the method definition of a. So since it only has a method definition of a, yeah, it's fine. But let's see what this C might see. So since the C has its own definition B, it is expecting that even if I call A or B, it should work fine because I am a reference of the child. So my object will have all the definition of A and B, but it's not the actual behavior since the object that we are assigning is of the parent, and we might not have the implementation of B here. So due to this condition, it is not it is actually an error in Java. But there is another way that you can sort of achieve this. So let us say you have okay, let's say you have a parent here. Okay, so you have a parent who is pointing to an object of child. So a child will have A as well as B. Now to this class as parent, it will only know that the a method signature of A. It is not aware of the B. But the object that we have is actually having both the method definitions of A and B. Then in this case, can I convert this into the object of child and reassign? Yes, we can do that using this a special syntax called as the down casting. So using this syntax, so you're saying, okay, so now this C can be pointed to this object. As a developer, I am enforcing that this is definitely of the child, so I am kind of typecasting it, or I am downcasting it and assigning it to this child reference. So this is another way we enforce the polymorphic behavior. So that's all in this video. We'll see you in the next one.